Let's look at section 11.7, events involving and conditional probability. So we are going to look at the probability of one event and then a second event occurring whenever one doesn't change the other one, and then conditional probabilities. So first, with fractions, remember if you add or subtract, you have to have a common denominator. So on this, we have 60 and 20. We can use a common denominator of 60, so that means I need to multiply top and bottom by 3. And I keep the same first fraction. I go ahead and multiply to get the second fraction. We'll go ahead and subtract. We can simplify by marking out common zeros. That's the same as dividing by 10. So we get 1/6. Okay, independent events are when one event occurs that has no effect on the other event. So when we have probability of events like tossing coins or rolling a die or um, anything else like that, we just multiply the two probabilities times each other to get the probability of both of those events occurring. So the first one that we'll look at is a roulette wheel. So we have a wheel that has 38 slots. 18 are black, 18 are red, and 2 are green. The ball can land on any slot with equal probability. What's probability of red occurring in two consecutive plays? So probability of red and red. So you do probability of red times probability of red. So the probability of getting a red is 18 out of 38. And the probability of getting a red again is 18 out of 38. So we multiply these. You can multiply straight across and simplify, or you can simplify before you multiply. Either way, I would simplify both of these by 2's because they're both even. And then multiply straight across. And then see if you can simplify from there. I don't think you can. Nope, sure can't. So we'll leave it just like that. All right, the next one, we have a spinner. And they're equally spaced. We have blue, 3 blues, 2 purples, and 1 gray. So we have a total of 6 spots. So it says you spin it twice, find the probability you'll land on a color other than blue, so it's not blue, which is called the complement of blue, for each spin. So not blue, blue is 3, not blue is 3. So 3 out of 6 times 3 out of 6, which we could reduce these 1/2 times 1/2. Multiply top, multiply bottom, so it's 1/4 of getting 2 not blues. Here's another spinner example. On probability they'll land on purple, and then blue, and then purple. So probability of blue. Oh no, purple first. There we go. Probability of purple, then blue, then purple. But the order really doesn't matter for writing down probability. So purple, there were 2 out of the 6. Blue, there's 3 out of 6. Purple again is 2 out of 6. I'm going to simplify these. I'm going to go ahead and simplify by 2's here. 1/3, simplify by 3's. Simplify by 2's. And then multiply straight across. 6 times 2, 3 times 2 is 6, times 3 is 18, so 118. And the next one. Single die is rolled twice from the probability of rolling an even the first time. And then probability of rolling a number greater than 2 the second time. So even would be half because we have 1, 2, 3, 4, 5, 6. So here are our evens. So it's 3 out of 6 or 1 half. Greater than 2 would be 1, 2, 3, 4 out of the 6. Multiply straight across, or we can simplify first and divide these by 2. No, 2/3. We could also simplify diagonally 2 and 2. These both become 1s. 1 times 1 is 1. 1 times 3 is 3. If you don't like simplifying, you can multiply straight across and just simplify at the end. All right, let's look at independent events in a family. If 2 or more events are independent, we can find the probability of them all occurring by multiplying their probabilities. Probability of baby girl is 1 half. So the probability of 9 girls in a row is 1 half used as a factor 9 times. So 9 in a row. So it'd be 1 half times 1 half, times 1 half, 9 times. But an easier way of writing that is 1 half to the 9th power, which with a power, you can put this in the calculator, or you can make sure that 1 gets taken to the 9th power and 2 gets taken to the 9th power. Well, that's just 1 times itself 9 times. 1. This is where I use the calculator. 2 to the 9th, 512. So 1 out of 512. Okay. Probability of die and coin. So let's say you tossed a coin and rolled a die. Find the probability of getting a tails. And then find the probability of getting a number greater than 4. So tails is a half because there's heads or tails. And then a number greater than 4 would be 5 and 6. So that's 2 out of the 6. Multiply straight across or simplify. I'm going to simplify. That's 1 times 1 and 2 times 3. It's 1/6. Hurricane and probabilities. The probability that South Florida will be hit by a hurricane in a single year is 1/15. What is the probability that will be hit by a hurricane 2 years in a row? The probability of a hurricane 2 years in a row. So it'd be like that. So whenever you do that, one is not dependent on the other. You could get a hurricane every single year. Just because you got hit last year doesn't mean you're not going to get hit this year. So it each has 1/15. So we go ahead and multiply those. Top times top, bottom times bottom. And so you might have to convert these to decimals. So let's go 2 decimal or 3 decimal places. Okay. Its probability of being hit is 1/15, so it's still 1/15. What's the probability it'll be hit 3 years in a row? So same thing, but we're doing it 3 times. An easier way of writing this, kind of like we did with the girls, 9 girls, you would do 1/15 to the 3rd power. So really I just need to do 15 to the 3rd power. And then I can change that. So it says e to the -4. That means I need to move this over scientific notation. 1, 2, 3, 4. So that's what that means. The e to the -4 means scientific notation, means times 10 to the -4. Because that's a negative, we move the decimal over to the left 4 places. If this was positive, we'd move the decimal over 4 places to the right. Let's see what's up next. What's the probability that it will not be hit by a hurricane in the next 10 years? So, probability of not a hurricane, this is called the complement, not a hurricane. So I could actually write this as like this. That's the complement of a hurricane. Way we could find that is do 1 minus probability of having a hurricane in the next 10 years. So this would be 1 minus 115, which we get common denominators. Basically, it's the opposite of this, the complement 14 out of 15. So probability of not a hurricane 10 years in a row means I need to do this 14 over 15, 10 years. Oh no, it's this 15 years. Right? Will not be hit by a hurricane. Okay. Will not be hit by a hurricane. So 0.50 to 2. Depends on what they're asking you to round to. All right, the next one is probably it will be hit by a hurricane at least once. So probability of events happening at least once is the same thing as 1 minus probability it doesn't happen. So the probability of at least one tornado, oh, not tornado, sorry, hurricane. I got my events confused. Means 1 minus probability of no hurricane in the next 10 years. So we're going to use this, do 1 minus 0.502, which I'm actually going to use the exact right here. Do 1 minus, I arrowed up to bring that down, 0.498. This would be 15. And you're just going to have to pay attention to how many decimal places it's asking you to round. I think it says 5. So just be really careful with that. All right, and probabilities with dependent events. So that means if one event occurs, then it's going to affect the probability of the other. So probability A and B, probability of B given A has occurred. So where you'll see this is if you are drawing marbles or picking from a box of donuts that we'll do on the example 7. If you take one out, it's going to stay out. You're not going to put it back in. So a lot of times you'll see this without replacement as the keywords. That means you'll take it out and not put it back in. All right, so let's look at the box of donuts. 2 dozen donuts, so we have 24, all identical in size, shape, color. 6 are jelly filled, 6 are lemon, 12 are custard. You randomly select one donut, eat it, and select another donut. So that means you're not replacing it because it's gone. You ate it. I'm probability of selecting 2 jelly filled donuts in a row. So probability of jelly, and jelly. So probability of getting a jelly for the first one is going to be a different probability from getting a jelly after jelly. Mhm. And the different. All right, so probably getting a jelly to begin with would be 6 out of the 24. Probably getting a jelly after you already ate a jelly would be you no longer have 6 because you ate one, so it's 5. You have 24, but now you only have 23 because you took one out. So you have to reduce these each by 1. So we can simplify it, multiply. I'm going to simplify it. So 1 times 5 is 5. 4 times 23, 4, just right here, 92. 5 out of 92. We'll write those as fractions. Okay, do another one that's similar. So this time you're going to get a jelly filled followed by a custard. So probability of jelly and probability of custard. So this is without replacement. So probability of jelly would be 6 out of the 24. Custard, you still have 12 custard, but you no longer have 24 total, you have 23. So that's the change on this one. Custard stays the same because we didn't pick it, but the total changes. So we'll go ahead and simplify. Divide by 6. Divide by 6. 1/4. Plus your across. 4 times 23. I think I just did that, didn't I? 92. Yeah. These are both evens, though. We could simplify. 92 divided by 2. 46. Oh, these are still even, so divide by 2 again. We should have simplified here. Okay, that's it. All right, let's look at another example. Consider a political group consisting of 8 Democrats, 8 Republicans, and 3 independents. Suppose that 2 group members are randomly selected in succession to attend a convention by the probability of selecting 2 Democrats. Probability of Democrat, probability of Democrat. So probability of selecting a Democrat would be 8 out of the total of what? 8 plus 8 plus 3, 16 plus 3 more is 19. So 8 out of 19. And then selecting another Democrat. Well, if you've already taken one out, it's 7. And your total is also reduced. So we need to simplify. Can't simplify that. Can't simplify that. But we can cross simplify. So 4 times 7 is 28. 19 times 9, 171. Here's another one. Find the probability of selecting no Democrats from a group. And we have 2, so probability of not a Democrat. Probability of not a Democrat. Remember that little line means complement means the opposite of selecting that. So that means that the opposite would be 11 out of 19 times, it's no longer 11, it's 10 out of 18. But we could simplify this by 2's. Multiply straight across. We just multiplied that and that was 171. Okay, conditional probability is the last skill that we're learning. This means that we are going to find the probability of event B, assuming that event A has already occurred. So it has this little line. You would say probability of B, and this means given A occurred. The number of discs shown are placed in a box, and one disc is selected at random. Find the probability of selecting a 1 given that a green disc has already been selected. Find the probability of 1 given green. So you only choose from green. So how many greens are there? 1, 2, 3, 4, 5, 6, 7. 7 total greens. How many ones do we have? We have just the one. So you don't include blue at all. We're saying we know we selected a green, so that's not even included. So there's 7. And then you want to see about selecting 1. Well, there's 1 of them, so it's 1 out of 7. Find the probability of selecting an even given green. So let's see. 1, 2, 3. We only have 3 greens, so that's our denominator. And how many are even? 2. So we have 2 out of 3. Okay, the last problem. This is a real-world example, mammography screening of 100,000 women ages 40 to 49. So we have breast cancer, no, positive, negative, and total. So let's find the probability of a woman having a positive mammogram given that she does not have breast cancer. So that means our denominator is going to be out of the no breast cancer, that no breast cancer total. How many of those are positive? Yes. So we aren't even looking at these values. You only want to look at the total of no breast cancer, and you want to look at how many were positive. So these are basically false positives. And we would want to, let's see if we want to write those as decimals. No, you can actually simplify it. Let's see, I have one similar to that on those assignment. Yeah, it's going to be its decimal. So 6944 over 6.07. Or we can simplify the fraction as well. Math, frac, 700. All right, that is it for this section.